I have a Beko 40WLJ520HD with no picture. There is sound, as I will demonstrate now. But we have no backlight, and if you press here normally you'd see a little bit of backlight coming through. But I'm going to now take the back off and have a look and check out the inverter section and backlight section of this LCD unit. I won't show you the process of taking off the back. It's just a load of a few screws, and it'll just take up too much time in the video. Have the units on its face now, and as you can see, there's screening cans around the power supply over here, and we got this black plastic cover over the inverter section. I'm just going to remove this first and check my 24 volt supply to this, and I remove that by moving these little silver screws here. Have all the screws out, and here's our inverter PCB, and as you can see there, we got two fuses right here. Have a meter set up now, and we have our connector here, and our 24 volt should come in at this particular point here. Maybe I can zoom in a little bit. And that actually goes to these two fuses. So if I just zoom back out again, and you'll see my meter, and I'm just pressing the power button on the unit. And as you can see there, there's no voltage on that supply pin to this inverter section, so I have to go back now to the power supply. That's the next step. Got to remove this screening can now around the power supply, and the screws all around it here. There's about 5-6 screws, and I'm going to remove them and then remove that screening can. To get at this power supply, I got to remove this screening can, and this here. I've already taken the screws out of some of them. That's that out of the way, and that's that out of the way. And the reason you have to take that off is because you've got another two screws down here hid underneath the main screening can for the main PCB. That out of the way. And I can see straight away now the problem with this unit, which is very common to Beko. And if I just zoom in, you see the black. These connectors here get the dry giant or high resistance. They go high resistance, and then you'd see all this burning. And the way I cure this now is I solder these cables directly into the power supply, and I'll just remove the power supply and I'll show you this. I have my screws out, and as you can see from here, there's no damage done to the bottom PCB. The only problem is this connector now is melted onto this connector. It's not going to part without doing damage to the cables. So what I'm going to do is I'm going to unsolder the connector, and I'm going to cut the wires, and I'm going to resolder them into the same points. first thing I'm going to do is I'm just going to freshen up the solder. I'm not going to show the full process of this because I have enough videos out there showing how it's done solder. And then I could either use my vacuum solderer, but I'm going to use my desolder blade instead. And that would be the process till all the pins are unsoldered. Okay, it's all unsoldered now, and as you can see, it comes out, and you can see the burning clearly on that. And I really got to get back to some good cable. It's not, you see it there, it really does get hot all the way up on some of them. Heat goes up as far as there, so I'm going to have to remove that much cable off it. And I've got to be careful to put my cable back in the same spots. So I'm going to start with this cable. And as you can see, try and orientate it the same way. I will snip these wires about at this point here. That's the first one. I have the cable trimmed back, and I've tinned it with a bit of solder, and I'm going to put it now into its first number 1 pin. And I turn over the board. And then I will solder it in place. Then I will trim the excess. And what I do then is I do that with all the cables, and I put them in one by one, starting with pin 1, 2, 3 and all the way up. I only remove one piece of cable at a time, so I don't put them in the wrong place. I have my cables soldered directly into the PCB now. I have removed cut all the cables off, and as you can see, I just started off with cutting this one off, and I put into position number 1. Then I cut off the next one, put into the next one, and so on till I got them all done. They're soldered directly in, as you can see from the bottom of the PCB. What I'm going to do now is I'm going to plug it in now and test it to see did this cause any damage to the power supply. That's the next thing. Have my power supply back in place now, and I'm ready now for testing. I have the mains cable connected up. It's in standby, and I'm just going to come back here now to my inverter board, and I'll just show you. I can get this a bit closer. I'll take it out of standby. And I'm going to measure the voltage right there. And as you can see, we have 23.8 volts there now, and the LCD is up and working. There's my test hole. You can see the light from the backlights actually shining through these holes. You can see it there. So I know my backlight is up and working. So what I'm going to do now is I'm going to get it all back together again and see what kind of a picture I have. Covers are back on the power supply and the one that covers the signal board, and also I have the cover on here on the inverter board as well. I've taped this back up out of the way because we don't want it running too close to the signal board, just in case noise from the inverter board is transferred into your picture information. So we try to, if we can, keep it away from it. It is now ready for the back to go on. Okay, the back handstand is now on the unit. All the screws are in it. The unit is plugged in. I have a signal going into the back of the SCART connector. I'm going to just take it out of standby. Okay, as you can see now we have a picture. This problem with the connectors on the Bekos is very common. This chassis is also seen in other various models. I've seen it come as a Grundig, Bush, to name just two. I hope that's of some help. Thanks for watching.